March 7, 1944, 20,000 feet above Hannover, Germany. The canopy glass vibrated with thin ice and soot, while sunlight cut through a haze of contrails and distant smoke. A young American pilot hunched over his instruments and tapped the worn leather of his logbook as if marking a mood rather than a number. Below, wedges of B-17s rolled like iron islands through a sea of winter cloud. Their flaps glinted and their gun turrets sparkled like cold, desperate beacons. On that mission, more than 200 heavy bombers had pushed into Reich airspace, a formation that represented months of planning and thousands of lives invested in a single push against industry and will. For the German fighter pilots, the math of interception had been practiced and precise. Climb, cut the sun, engage the bomber stream at favorable angles. For the bomber crews, the calculation had been simple and terrible: survive until the escort arrived. Confidence on both sides ran close to faith. What no one yet grasped was how a single combination of airframe and engine would widen the battlefield and rewrite the escort doctrine in ways that would change the fate of those bomber crews and the men who flew against them. Within weeks, that handshake between power and endurance would move the line of safety miles closer to Berlin and force German pilots and planners to rethink what it meant to control the sky. The human images remained sharp in memory: frost-bitten fingers on cold yokes, radio crackle like an old wound, the smell of burning oil and rubber after an engine hit, the hollow clank of spent shells in a turret, and the patient silence of men who had counted too many funerals. This was the moment when the escort stopped being a guard and became a weapon of strategic projection. And the story that follows will show how P-51 Mustangs carried that transformation from testing fields to the heart of German airspace. The opponent seemed untouchable in the months before the Mustang proved decisive. The Luftwaffe had honed interception into an art. They organized fighters into rotating patrol rings, exploited cloud layers as concealment, and timed attacks to when the bombers were most vulnerable. Intelligence reports cataloged success rates that read like doctrine. In one campaign log, the Germans recorded a mean interception success of 42% of targeted bombing formations, a figure that turned heads in Berlin and became part of briefings on national radio. Leaders were named and profiles circulated. Oberst Heinrich Vogel had earned the confidence of his wing with aggressive tactics and calm in the cockpit, a man who trusted mathematics and pilot skill equally. Squadron leaders boasted of aces who could outturn and outdive many Allied designs at the time. They had trained in simulated interceptions, perfected energy fighting, and exploited the ranges at which Allied escorts shied away. Behind the tactics lay industrial muscles. Factories hummed with assembly lines for radial engines. Crews were rotated through refresher flights, and fuel allocation favored quick interceptors. The Germans measured risk and rewarded it. To many Allied planners, it read as an almost machine-like dominance. Witnesses from both sides remembered the precision of German formations, the low ferocity of attacks, and the almost surgical targeting of bomber tails. Testimonies from survivors carried a tone of inevitability. The sky belonged to those who had mastered the climb and the sight line. Yet within that dominance were vulnerabilities that numbers did not immediately reveal. Range and sustained performance at altitude mattered more than a raw turning moment. Those were the cracks engineers across the Atlantic began to study. Those cracks were logistical and technical, and they explained why domains seemed stable. Allied bombers flew long missions with limited fighter endurance. Their escorts were often short-ranged, bound to the coastline, or to drop tanks that complicated flight profiles and reduced agility. The bomber crews could not be expected to win dogfights alone. Their turrets were defensive and their speed was heavy. Fuel was a calculus written in gallons and minutes. Bombers consumed fuel like a ledger of sacrifice. Maintenance cycles meant that both plane and pilot fatigue reduced effective sorties. In numbers, the problem looked stark.
Typical long-range escort missions required fighters to operate beyond their designed ferry ranges, or accept that bombers would be unprotected during ingress or egress. A single engine failure or an overworked oxygen regulator at high altitude could decide a crew's fate. The Americans had assemblies of aircraft that were fast, maneuverable, and yet marginal on endurance. The mathematics of combat placed high value on two variables that did not naturally coexist in many designs: speed and range. Engineers and commanders argued over trade-offs. Pilots wanted speed to counter enemy fighters and climb to intercept. Strategists demanded range to escort bombers to the target and back. Logistics officers counted fuel lines and production queues. That tension between what designers could deliver and what doctrine demanded framed the work at airfields and factories. Flight logs, procurement memos, and mission reports showed recurring failures of escort coverage. A raid with insufficient escort might lose 10 to 20% of heavy bombers. Those losses compounded. Production had limits, and pilot training was a slow arithmetic. It was clear that without a change in aircraft capability, the bomber campaign's attrition would remain painful and perhaps unsustainable. Into that problem stepped an innovation that looked at the variables differently. The P-51 Mustang, in its evolving iterations, married aerodynamic cleanliness and the adoption of the Rolls-Royce Merlin engine in a way that addressed range and performance simultaneously. What had started as a private venture and a transatlantic exchange of ideas matured into something that warranted a doctrinal reevaluation. The designers refined laminar wing sections to reduce drag and paired them with an engine that provided high-altitude horsepower and a superior supercharger arrangement. Early tests on a wind tunnel strip had produced numbers that read like promises: higher speed at altitude, better compliance. Fuel consumption at cruise settings, and enough fuel capacity with external tanks to push ferry ranges to escort distances previously unthinkable. Engineers ran iterative tests and adjusted carburation, oil lines, and intercoolers. The development sequence involved field mechanics pushing engines to redline and pilots logging climb rates that edged past known intercept envelopes. Technicians began keeping meticulous charts, RPM curves, manifold pressure readings, and altitude performance tables that were shared with mission planners. The breakthrough was not a single bolt tightened, but a systemic rebalancing. Where previous fighters sacrificed fuel for speed, the P-51 configuration found an equation that offered both. A technical note explained it plainly. By combining a laminar wing with a high-altitude optimized supercharger and improved cooling, the aircraft reduced parasitic drag and preserved power band at mission altitudes. That description could be condensed into procedure for factories and squadrons to replicate. The work involved men like Thomas Reed, an aero engineer from Ohio, and Maria Alvarez, a lead mechanic who perfected carburetor tuning in cold conditions. It involved institutions the likes of North American Aviation and oversees the engineering house that maintained the Merlin series. Their combined effort changed designs into a deliverable asset for the air war. The first flights that proved the Mustang's promise were small and discreet, and then suddenly larger and decisive. In a testing field outside London, pilots and engineers watched climb charts creep upward and turn times hold steady even with external tanks. Dialogue in the hangar captured the tentative hope and technical skepticism that coexisted. "How much extra juice do those tanks give us at cruise?" asked Major James Carter as he stepped toward a polished fuselage. "Enough to get to Berlin and back with an escort window," replied engineer Thomas Reed while wiping oil from his hands. "You sure about the cooling at 25,000 feet?" asked Captain Walter Briggs. "We've rerouted the oil feed and adjusted the intercooler flaps," said Maria Alvarez. "If she holds those numbers, we can change doctrine," said Lieutenant Samuel Hayes with a half-laugh. "Then we push 'em out in numbers," said Colonel Edward Shaw, who had authority and appetite for risk. "Not all at once," said Reed. "Staggering will keep attrition manageable at first." "We will need pilots ready for long-range navigation," said Briggs. "And pilots who can conserve rather than burn through climb," said Hayes.
The exchange went on and on in the hangar, with practical anxieties and aspirations laid bare. The conversation was punctuated by sensory detail, the metallic smell of fresh paint, the rasp of a nearby compressor, the taste of winter damp on breath, hands warmed temporarily by a borrowed coffee tin, and the faint vibration underfoot as test engines idled. Those first sorties were not glamorous. They were calculated routines of adjustment and measurement. But each successful return with full fuel gauges and serviceable engines reduced doubt and increased a willingness to scale the experiment into operational deployments. When the first P-51s entered combat as long-range escorts, the early missions were tests of both machine and doctrine. The exchange between pilots in the cockpit and those on the ground filled radio logs. "This is Razor 1. I have visual on bomber stream at 12 o'clock high," came the clipped report. "Razor 2 copies. Continue escort pattern," replied the lead. "Enemy singles peeling off to port," said a wingman. "Take the leadiest target," said another voice. "I am low on rounds for the nose gun," replied a tail guard. "Keep tight formation and mark the box," came an authoritative call. "How much longer to target?" asked a nervous bomber captain. 10 minutes and holding altitude," the reply. These exchanges numbered 8 to 10 in many mission logs and revealed an evolving choreography between escort and bomber. Sensory notes in mission reports documented thin air that made voices tinny, the smell of spent cordite, an acrid taste when a nearby bomber took a hit, and the roughness of frost on the inside of a canopy. Pilots reported surprise when enemy fighters that had previously dominated certain altitudes found themselves countered and sometimes frustrated. The first tangible sign of strategic change was when escort losses dropped and bomber loss rates moved from catastrophic percentages to survivable margins. A single mission near Berlin recorded that rendezvous coverage remained intact across a full ingress and egress, and that bomber formation integrity held, a result previously rare. The psychological and tactical impact was immediate and amplified. German pilots who had once treated bomber streams as their hunting grounds began to find escorts persistent and aggressive at ranges that were formerly safe. Reports from Luftwaffe units described confusion and stress as more long-range escorts engaged fighters near targets and overlapped patrol windows. Testimonials from German commanders mentioned surprise that escorts could now shadow withdrawal routes and punch into kill boxes where they had felt secure. Allied flyers revealed a different reaction, a sense of relief that lowered the background anxiety and an increase in combative confidence. Radio chatter changed from flat logistical calls to sharper tactical communications. Pilots began to speak of choosing targets and maintaining offensive posture rather than praying evasive maneuvers. Descriptions of combat included sensory detail to underscore the shock of the moment, the smell of glycol after a cooling line failed under fire, the taste of adrenaline like metal at the back of the throat, the thudding in the chest when tracer rounds stitched open a wing, the sight of a Messerschmitt rolling away with black smoke, and the sound of an open throttle pushed to sustain a climbing dogfight. That shock compounded into strategy. Commanders on both sides adjusted orders. Allied planners started to route escort corridors deeper into enemy territory. German staff wrestled with how to adapt to a new pattern of persistent escorting that cut their window of safe engagement. Then came the campaign that consolidated the change and made the Mustangs synonymous with escort success. Across multiple missions, the P-51s were used en masse to protect bomber streams on raids deep into German industrial heartlands. Numbers mattered. Squadrons flew hundreds of sorties over a concentrated series of weeks. The new doctrine emphasized continuous escort coverage, refueling logistics, and pilot rotation to maintain stamina. Specific operations were recorded that moved sortie counts into the thousands and demonstrated a rapid drop in bomber attrition. In one campaign log, a theater commander noted that bomber losses over 4 weeks fell by nearly 60% relative to the previous quarter, while fighter attrition against escorts remained manageable. Tactics evolved. Mustangs would climb to altitude with external tanks, rendezvous with bomber boxes, jettison tanks near the coast, and then engage enemy fighters at the target zone. The procedural manuals were updated with revised climb schedules and radio discipline. Pilots and planners learned to leverage speed and endurance together. Intercepts that once favored German energy tactics now required different responses. Dialogue between commanders often read like a chess match. "Keep two groups at high cover and one group shadowing low," said a planning officer. "Rotate the leaders every 2 missions to keep fatigue down," came a reply. "Maintain spare parts pipelines and prioritize turbo supercharger maintenance," another voice added. The sensory reality of this campaign was tangible. The smell of freshly laid fuel lines in the hangars, the warmth of welding arcs in factory bays, the mechanical rhythm of production lines, the dull ache in pilots' shoulders from hours in heated suits, and the sound of massed engines like a rolling storm on the horizon. The campaign became the turning point in public morale as well. Broadcasters highlighted the increasing success of bomber missions and the shrinking lists of casualties from the days when escorts could not reach the heart of the Reich. Attrition, scarcity, and eventual collapse of some German air defensive calculations followed in time, but not without cost and contention. German production lines had been strained by combined bombing and the diversion of materials to fighter production. Fuel shortages amplified the effects of sustained Allied pressure. Training pipelines could not replace experienced pilots at the same rate as losses occurred in certain months. Statistics began to tell a grimmer story for the Luftwaffe. Sorties flown declined, while maintenance times lengthened, and the average flight hours per fighter pilot fell. Reports from squadron level included mentions of pilots being rushed into action with insufficient training hours, and older pilots who could not match the stamina of younger Mustang pilots on long escorts. The human cost on both sides remained severe. Personal diaries recorded missing comrade names, engines silenced forever, and families that waited. A factory foreman, Joseph Miller, logged overtime and the smell of burnt solder, knowing each aircraft that left his line carried both pride and the weight of survival. The German side had to redistribute fuel and rebuild tactical doctrine to attempt counters such as head-on attacks and massed fighter sweeps, which required more fuel and more risk. The arithmetic of production versus loss shifted against them. An intelligence summary near mid-campaign wrote that without a significant increase in fuel and trained pilot throughput, the Luftwaffe would struggle to sustain its previous dominance. That calculation fed decisions at higher strategic levels and ultimately helped shape the course of the air war. Personal backstories gave texture to the machines and doctrines at work. Major James Carter had been born in a small Nebraska town and learned to fly on a rickety biplane over a cornfield. He had been the kind of boy who read technical manuals for pleasure and could name each bolt in an engine by sight. At 25, he joined a pursuit squadron and mixed a pragmatic cool with an impatience for bureaucracy. He had lost a younger brother in a bomber crew earlier in the war, and that loss burned into every mission planning meeting. His marriage had become a series of postcards and promises he was not sure he could keep. He carried sketches of the P-51 in the pages of his logbook as if it were a talisman. When presented with the Mustang, he saw not only a plane, but an answer to a debt he felt toward bomber crews who had no real chance without consistent escort. He argued with commanders and comforted mechanics, and in the quiet of night, he wrote letters home that tried and failed to explain why he kept flying. His convictions were technical and ethical at once, and they guided his leadership. Colonel Heinrich Vogel had a very different arc. He had risen through the ranks in the Luftwaffe on skill and ruthlessness, trained in energy tactics, and had survived the attritive first years by maximizing limited resources. He had been decorated and respected, but he had also endured the erosion of supply lines and the weight of strategic decisions handed down from distant command. Vogel had studied Allied aircraft with analytical patience and accepted loss as part of operational realism. He mistrusted rapid doctrinal changes in favor of technological answers and believed in the relentless execution of tactics he had honed. That tension between his tactical conservatism and the sudden arrival of long-range escorts put him in a strategic dilemma. Both men carried personal histories that informed their choices and their responses to the evolving air war. Scenes of tension punctuated the campaign in visceral episodes. In one encounter near a steelworks, 3 Mustangs broke into a concentrated fight where a head-on attack threatened a bomber formation. The dialogue over the radio was terse and rehearsed and lasted barely enough time for life to change. "Brake left, engines overheating," said one pilot. "I cannot hold that line, fall back and cover the tail," another replied. "We must not let them reach the box, push through," shouted a senior voice. The exchange lasted less than a minute and decision cycles happened in heartbeats. The sensory register included the metallic snap of cannon fire, the smell of hot oil, the masked shouting dampened by oxygen masks, and the taste of grit when a canopy crack showered the cockpit. The tension ended in either survival or loss, and the witness reports afterward carried lists of names and equipment states. Another tension moment took place in a factory when a critical batch of supercharger impellers arrived warped. Engineers argued for retooling and delays, while commanders pushed for release to maintain sortie rates. "We cannot risk catastrophic failure," said Reed. "We will lose missions and men if we hold," said a logistics officer. "Find a temporary fix and mark those parts for immediate inspection," ordered a production manager. That bureaucratic tension resolved after heated debate into a compromise that mitigated risk while allowing deliveries to continue, but it left technicians exhausted and morally strained. Each of these moments carried short narratives of crisis resolution and human cost. Technical explanations appeared across the narrative to ground claims. A procedural note on the Merlin installation explained that the conversion required rerouting of oil feeds to maintain pressure at altitude, adjusting carburetor jetting to prevent mixture lean-out, and ensuring intercooler ducts were sized to prevent detonation episodes at high manifold pressures. This concise description allowed mechanics to replicate the steps and provided commanders with a checklist for maintenance priorities. Another technical passage described the laminar wing advantage in plain language. A smoother wing profile reduced turbulent flow over the surface, and that meant less drag at cruise speed, which translated to fuel savings and higher top speeds at altitude. These passages were short, verifiable, and directly linked to operational outcomes. They bridged the language of engineers and pilots and became part of the field manuals that accompanied Mustang squadrons into service. At around the 1/3 mark of the narrative, pause here and consider the dilemma that shaped engineer and commander decisions. If you were the engineer in that hangar and had to choose a compromise for a new fighter design, which would you pick first, speed or range? Type speed or range, and then add a brief reason why. Choose the single word and a sentence because the choices made at that bench table rippled through missions and lives and shaped what a pilot felt over storm clouds. For some, the argument was visceral and practical. The pilot who had to close with an enemy wanted speed to turn fights into opportunities. The strategist who watched bomber formations burn wanted range so that the escort could be present when it mattered. Both perspectives were valid, and both had costs. When readers share their choice in the comments, they help a community that cares about the trade-offs that shaped history. Now back to the flight line where decisions were being tested in the air. The invitation to answer in the comments was designed to collect small judgments that mirror large historical choices and to make the audience part of the narrative of engineering ethics and battlefield consequence. In the campaign phase, the Mustang's role matured into a doctrine of projection. Squadrons rotated through a choreography of sorties that balanced maintenance windows with maximum coverage. The numbers scaled, and with scale came logistic strain. Spare parts pools had to be rebuilt, fuel allocation confirmed, and pilot rest cycles mandated. The operation logged thousands of sorties, and the math showed sustained reductions in bomber losses while maintaining acceptable fighter loss rates. Strategic consequences followed. Industrial production in target zones suffered more interruptions because raids reached deeper and returned intact. Morale on the home front shifted as casualty lists shortened and reports of successful raids increased. For the Germans, the cumulative effect was disorientation in earlier plans and a forced reallocation of resources to counter long-range escorts. They attempted countermeasures such as massing fighters in concentrated sweeps, increasing faster climb profiles, and experimenting with tactics that could exploit transient gaps. The attrition statistics grew less favorable. Production strain and fuel shortages meant fewer replacements at the same quality. Pilots were stressed, and the experiential gap widened. The human consequences were measured and remembered. Men like Lieutenant Samuel Hayes wrote postcards that read like fragments of philosophy. Maria Alvarez kept maintenance logs scribbled with small doodles of planes and notes about crew morale. Pilot rosters listed names removed forever, and airfield hums sustained the weight of absent voices. Factories marked production milestones not as triumphs alone, but as solemn obligations to men in flight gear. On the German side, names like Heinz and Klaus became entries in lists that German families would later receive. The cost was both statistical and moral, and it reshaped how air campaigns were planned in the remaining years of the war. 1 month after the decisive campaign, the operational books showed a sharp change in metrics. Escort coverage had increased by nearly 50% in critical windows, and bomber survival rates had risen accordingly. Pilots reported psychological relief and a new willingness to press attacks closer to defended targets. In commanders' reports, the word sustainable appeared with cautious optimism. The immediate tactical effect was that bomber missions became more predictable in their success rates and less subject to catastrophic surprise. The industry responded to production spikes, and maintenance protocols adapted to the increased usage rates of high-performance components. Local airfields coped with greater traffic and crew rotations, which required expanded housing and logistics. Families began to feel an easing of dread as casualty reports for some units fell, but the relief was measured and uneven. The human cost remained visible in veterans' memoirs and in the long queues at late-night repair bays where mechanics patched armor and men awaited orders. 3 months later, the strategic landscape had shifted more decisively. Supply lines and fuel availability for German units had become chronic constraints. The Luftwaffe struggled to match the tempo of Allied operations, and the attrition of experienced pilots became a compounding factor. Allied bombing campaigns could be planned with deeper confidence, and strategic targets further inland were
placed within operational reach. Industrial output in key German regions declined as raids combined with internal resource misallocations. Reports from intelligence units documented a growing shortage of trained fighter pilots and an increase in novice crews facing seasoned Mustang pilots. The political leadership took notice, and emergency meetings adjusted priorities, but with diminishing returns. On the Allied side, planners faced new logistic challenges to keep escalation sustainable. But the net effect was a clearer projection of air power that supported broader operational goals across multiple theaters. 6 months after the initial Mustang missions, the legacy was visible in doctrine and production. Long-range escort had established itself as a fundamental requirement for strategic bombing campaigns. Aircraft designs and Allied inventories incorporated lessons from the Mustang program, and manufacturing processes had been refined to improve throughput and reliability. Bomber losses had dropped significantly, and this reduction had a multiplier effect on aircrew training cycles and morale. The German air defense system had been forced into a defensive posture, requiring more resources to maintain shrinking operational windows. The numbers summed into strategic advantage. Historians later would point to the Mustang era as a turning point in the air campaign, one where technology and production intersected with doctrine to change the calculus of aerial warfare. The human stories remained the core of that legacy. Pilots who survived came home altered. Mechanics kept to themselves the nights they spent welding and sweating to keep an engine alive. And the families of the fallen kept the memory of names and letters that conveyed both valor and loss. In the final analysis, the P-51 Mustang did more than escort bombers. It changed the geometry of engagement and the expectations of protection. It raised the cost of air defense and forced opposing commanders to reconsider previously tested tactics. The strategic consequences were measurable in sortie counts, production ratios, and reduced attrition. But they were equally evident in the faces of men who returned from missions and in the silence where voices once were. The day when the sky changed had a price and a legacy. The last lines of mission reports were often factual and cold, but the human margins told the deeper story. Of the thousands who flew, some returned seasoned and hollow. Others never returned, and those who did carried stories that no statistics could fully capture. If this account moved you, comment below and tell us which choice you would have made in the hangar, speed or range, and why. If you want more accounts that merge technical detail and human testimony, subscribe to follow further episodes where we examine the machines and the men who made the skies into decisive ground. This is the story of how one aircraft and a chain of human decisions altered the fate of bomber crews and the men who hunted them. A turning point written in metal and fuel and in the courage of those who took to the sky.